Should we get started?
It's recording.
All right. Well, welcome to our second to last TWeD talk of the spring 2013 term. Today, Evan Patton is going to give us an interactive presentation on developing semantic web apps on the Android, the MIT AppInventor platform. Just a couple reminders. Number one, this is being recorded and also broadcast out on the interwebs. Number two, if you haven't already, and most of you haven't, signed up for next week's end-of-term lightning talks. If you go to the TWeD website, tw.rpi.edu/web/TWeD, and scroll on down to next week's schedule position, there's a link to the sign-up Titan pad. And we appreciate as well as your name, your topic, although you can change your topic. And as it says, the only reason for not signing up is extreme travel or sickness. We already have one person who is extremely traveling to Paris. So, without further ado, Evan, take it away. Thank you.
Yeah. Thanks, John. So, welcome, everyone. I guess just as a warning before we start, this is a lot of preliminary work. We started working on this about 3 weeks ago. So the AppInventor, of course, is much more stable, but we're adding a lot of linked data features to the AppInventor. And so all of these are being implemented, and you will probably find bugs as we go along. And of course, if you are interested in helping, and you have free time, or if you don't have free time, just let me know, and I'll have my contact information up at the end, and I can talk to you more about how you can participate in building linked data into the AppInventor. So just a quick overview. Just going to give a brief introduction to kind of the history of the AppInventor. I won't really go into semantic web because all of us here work in semantic web. And the concepts we're dealing with are relatively straightforward. We're not doing reasoning or anything like that. It's just simple linked data. I will give you an overview of the AppInventor designer, take you through the UI there, the blocks editor, and then talk a little bit about some of the semantic extensions we've added in the past few weeks. And then lastly, we'll get to doing some actual app building, and hopefully all will go well there. So, just as a history, AppInventor kind of comes from two different trains of thought. It kind of originates from Logo and it inherits a lot of its design from Logo. On some versions that followed, Star Logo, the next generation. Some of the work that was done for the Lego Mindstorms kits, which are also supported by MIT, the Scratch programming language as well. So the idea is that it's kind of meant to inherit from all these different things this very straightforward visual way of building applications and kind of making computers do stuff. And the idea there being is that you can use it as an opportunity to teach kids or people who don't have any programming background kind of how to do some basic programming. And of course, the difference here is that this is doing it on the Android platform, which means that you can actually build an application, go out into the real world, and play around with it. So, what exactly is the AppInventor? It's a tool for visually constructing Android applications. It's a combination of web and local. So the designer, which we'll get to in a second, is web-based. You just open your browser. It's built in GWT, and it will work on Chrome, Safari, Firefox, and Internet Explorer. And you go and you kind of drag and drop components into the interface, and then there's a local application that provides a blocks editor where you actually kind of build your code out of blocks. And then it has all of the necessary components, so you can do things like have it push the code to your Android device if you've got a phone in debug mode hooked up to your computer, and you can actually go and debug it and run your code and play around with it. And again, from the logo and the Scratch inheritance, it is again trying to help non-programmers kind of learn about how you design apps, how you do app development, and not having to deal with all the technicalities of what is a GPS location provider and what is a static class and all these other things. So it's really meant to give you a very high level introduction and allowing you to use all of the features of the phone without having to get into the nitty gritty of learning Java. So this is a screenshot of the interface, and we'll play around with it in a few minutes. At the top here, you've got a lot of controls that allow you to browse around. The key item that you probably will want to be using, and we'll get to it, is the box editor. And there's a button at the top there to open that up. You can also package it in a number of different ways. It will build the Android application bundle for you on a build server. And then you can, for example, it can give you a barcode, and you just scan the barcode with your phone to download the app, or you can download it and upload it to a web server, or directly to your phone, and all sorts of different mechanisms. The next is the palette, the design palette. This is where you get all your components. There are a number of different categories. You've got buttons and text boxes, all the basic things you would need to build some Android applications. It's not a complete feature set. I mean, it doesn't implement every single Android view, for example. But the idea is that it's enough to get people started, and of course we're working on a number of ways to start visualizing data, for example, adding maps that can render or sparkle results and things like that. That's not going to be in this presentation, but potentially in the future we'll do a demonstration of that. The kind of centerpiece here is the viewer. This is where you have all of your screens defined, and then into your screen you drop your various components. And then, of course, you can rearrange objects just through normal drag and drop. For non-visible components, so components that have behaviors but don't really have any visual element to them, we'll talk about the semantic web component in a second. This is one such component where it doesn't have an interface. It will drop it down here, but it allows you to still manipulate it. You'll also see there's a list of components, so sometimes you may have a section of your application that's invisible until the user executes some action and you want to display it. It won't actually show up here if it's marked invisible. Once you actually need it and you need to manipulate it, it will be over here on the right-hand side. This allows you to kind of manipulate things that you can't see in the editor. You can upload media, so you can do sound effects or videos or any media you might need for your application, you upload there. And then lastly, there's the properties window where you can actually manipulate various appearance and behavior characteristics of each of the different components. So blocks editor is where you actually do your coding, right? So the designer is just really meant to give you a WYSIWYG for your application's interface. But the blocks editor is where you actually provide the intelligence for your application to do anything other than look pretty. At the top, again, they've got a sequence of buttons. For our talk today, we're going to be focusing on the emulator. If you actually have an Android device and you've got a cable, you can feel free to try to debug things on your phone. But for the convenience of doing the presentation, so everyone can see it both here and on the web, we're going to use the emulator. Then on the left side here, a similar setup, but you've got a palette where you can see a bunch of different categories. These categories provide you control structures, tools for manipulating lists and text, and all of those types of things. You can also reference the different blocks you've defined under the My Blocks heading, where if you've added a component to the screen, for example, you can manipulate that component programmatically. And then you'll see here, kind of in the center, if you click on one of these headings, you'll get a little pop-up here where it shows you the various components that are underneath that heading. And so I clicked on control, and here are some of the different control constructs. You can see we can scroll so there are more, but the idea is that all of your blocks will eventually show up here as you add new components. For example, here's the choose component. You see it has a number of different features. It's got a little nub on the end here, which allows it to connect, and that is basically indicating that it returns a result that you can use, for example, to either in a set operation or in another comparison. It can accept these various nubs, which means that you can, for example, this is called test, so obviously you would have some sort of logical test here, and for example, it will generally test to see, this would be specified as Boolean at the Java level, and so it will do some type checking so that you can't just put a string here, because it can't cast a string to a Boolean necessarily. And then there are these nubs here pointing downwards where you attach other blocks of executable code. And so that's what allows you to structure your program sequentially and to say if, right, so this is basically saying choose this test. If it's true, then do this thing and return some result. Otherwise, do whatever is defined in this block and return some result. And you'll see when we go through this, building some applications, that these things kind of can expand and contract based on how much stuff is put inside of them. So you look at this and you say, well, I can't fit anything in there. You can actually dynamically expand to accommodate your entire program. So, semantic extensions. We've been working on a number of different things. They're listed here, the four basic ones. Semantic web component is kind of the central unit, if you will, to accessing semantic web content. It's actually powered by Jenna. We have a version of Jenna on the phone. It's not Android Jenna. It's actually Jenna minus a few components. So it can do full Sparkle queries on endpoints. It has the models and on models, although we haven't gotten rule engine working yet. That's one of the next potential steps. And so this kind of provides you your interface using Jenna to the semantic web. The next is the semantic form, which is a layout in the AppInventor. You provide controls to it, and then it uses the information on those controls to build an RDF graph. And you specify, for example, what the concept this form represents is. So you can say, we can create a form and say this form is going to represent fourth person, and then any object it generates will be typed fourth person in the model when we triple fly it, if you will. And the next thing here is the semantic list picker. The idea here is that it runs a Sparkle query. So given a concept, fourth person, go to an endpoint, run a Sparkle query that is essentially select all objects of this type, right? So select all fourth person instances. And then it uses that to populate a list that the user can then choose from and get a value back to the application. It will select the RDFS label to actually label the object. So instead of dumping a giant URI to your end user, you're actually just showing them a label, and then in the code you get the URI back to make it convenient for both displaying content to the user, but also interfacing with everything at the URI level. And then there's the text field, which is actually part of the normal AppInventor, but we've added a few capabilities to it. So, for example, you can type it, you can give it a concept URI, and if it's XSD integer, for example, it will know to apply the integer to it. You can also type it as an actual URI. You can say that this field will contain a URI that is a fourth person. But generally, for things like that, you would want to use the list picker instead. And it can also do some other transformations with respect to XSD. So it's kind of aware of what the different XSD types mean. And that makes it a little bit easier, so you don't have to understand all that when you're developing something. You just tell it this is what this is going to contain, and it does the work for you. all of this is powered by some new fields we've added to the property editor. And basically these fields are powered by an autocomplete system backed by ontologies. So when we build the AppInventor, we give it a list of ontologies. We say, when you start, load all these ontologies in, index their labels, and then we actually search on the labels. So as you start typing into this field, it will go and it will query, perform a Sparkle query looking for labels containing whatever you've typed, and then use that to populate a dropdown. So in this case, the particular project we're working on at MIT, they're interested in disaster management. And so they've found a handful of disaster management ontologies, which we've loaded into this. And so you can see here I've typed the start of population, and then it comes up with a number of different classes from those ontologies containing the term population, or populated place in this case. And so your app developer can start typing, and then it will find relevant classes, and then they simply pick the one with the label that matches what they're looking for. And so all this is basically powered by AppInventor plus a semantic web service, again backed by Jenna, which performs all the querying and actually populates itself at startup. So let's do a demo. If you are following along, there's a URL here. It's basically orion.tw.arc.edu:8888. And this will actually get you into the AppInventor. It will ask you to log in. There's really no authentication mechanism, so you could just, if you want, you can just put in your RPI email or your Gmail. We're not harvesting them to sell to people. I will log in as the administrator, which is basically just a test account. And conveniently, I've already done so. So the first screen you'll come to is going to look pretty empty. In fact, it will look even more empty than this one does, because I created the sample project. And this is your project interface. This is where you'll see a list of all your projects that you've created. So you could come in here and make 4 or 5 different projects if you wanted to. If you have like a class, for example, where you want to build a mobile semantic web app, you can you could come on here, make a new little project, my class project, and then work on that. Basically, you come up new here, this new button, click on that. It will prompt you for a name. The limit here, unfortunately, it doesn't say it, but it's basically limited to alphanumeric characters plus the underscore. So if you try anything fancier than that, it will complain at you. But basically, put in a name. I've chosen sample project here, so we're just going to pop into that. I'm going to clean up.
So, Evan, just
yes.
So we're going to this instance of AppInventor on Orion because it has the semantic extension.
Yes. So yeah, this particular version has all of the new code that supports the semantic extensions. We haven't quite figured out that when or if any of this is actually going to make it back into the other AppInventor, the actual mainline branch at MIT. But it's open source, which means that we can fork it if we need to, and just say, well, here's the semantic AppInventor. But we feel as though there's a lot of opportunities for if you can access the linked data cloud, for example, and automatically have a ton of data for using in your app, that potentially that's a good way of getting people into apps. Instead of them having to try to populate all that data themselves, they just go out and try reusing other people's data. How you would go about discovering that is it's a different research topic, which won't be addressed in this talk. So here's the interface, as previously discussed. Let's try something. Let's see what we should try. So there's a category here, semantic web, which has our semantic web components in it. Again, the text editor is previously existing component. It's in basic. It's not in the semantic web section. But you can come in here. You can grab a semantic form and drag and drop it into the screen. And you see right now it just is basically empty bounding box. You can do things like adjust its width and its height. So I'm going to come in here and just say that I want it to fill its parent in the width. You'll see it now it's expanded to take up the entirety of the screen in terms of the width. You can then come in. For example, we could go and grab some text boxes. I'm just going to make a simple form for creating a person. So text box 1, we can give it a hint. The hint will basically be, it will show whatever you type in here in the text box when the user is presented that text box and it's empty. So we could type in first name or given name. And you could say, this is going to be, I'm going to type in name. You'll see I get the drop down. And then I can choose, for now I'll choose first name. You can also provide default text if you prefer to have actual text in the text box and so on and so forth. So most of these are probably pretty self-explanatory. I'll just go through the semantic ones in full. There's concept URI, which defines the type of whatever's typed in here. In most cases for text box, you can just leave it blank and it will automatically infer that's an existing string. It won't actually type it like that in the RDF, it just leaves it untyped. Property URI specifies the property. And so this is whatever contains this property, whatever the value of this thing is in terms of the triple, right? So the parent of this thing is the subject, this is the property, the value of this thing is the object. There's also a subject identifier right underneath that. And basically we use this in the semantic form to help auto-generate URIs. So rather than you having to go through all the string manipulation in the code edit, in the blocks editor, you can actually just check this box and it will use that information to help generate the URI. So I'm going to go ahead and check that. And so basically the URI will be formed by including the value of this text box in the URI. Now I will do the same for the second text box. Well, let's go back here. I'm just going to name this so when we get into the coding, it'll be more clear what it is instead of text box 1, text box 2. So we'll call that one first name. We'll call the second one last name. Again, we're going to leave concept URI blank. We're going to, instead of first name, choose last name for the property. And again, I'm going to select that I use this as the subject identifier for my URI. And so basically what we're going to end up getting here is a URI that is a concatenation of first name and last name. Okay? And then the last thing we're going to need to probably do here is set a base URI. So this is the semantic forms properties now. All these are pretty much defined by us except for these last two here. Base URI is basically used by the system to act as the authority for all your URIs, right? So it becomes prepended to whatever the actual URI is. So you know, if you had a particular machine that you're hosting the data on, that you're generating from this application, maybe you would include that as part of your base URI. Because this is an example, I'm just going to use example.com. You can give it the concept URI. So again, this is instances created by this form. What type are they? So here we're going to say person. And then the remainder of these we can leave blank, but I'll just describe them here. Inverse property is for when you have nested forms. You can actually, instead of generating a triple SPO, it will actually reverse that and generate the triple OPS. So you can, for example, if you maybe had, let's see, good example. you could, for example, have an image, and maybe instead of wanting to say faux depiction, you want to say faux depicts or something like that. You can have it reverse the operation. The next thing I'm going to add is our actual semantic web component. So this is a non-visible component, so it gets shuffled down to the bottom of the screen here. And it has two fields, base URL, which is basically the equivalent of the base URI on the form, but it will apply to any form that doesn't have a base URL. And then endpoint URL, which is the actual Sparkle endpoint where any operations are going to occur. And so for the purposes of demonstration, I have set up on Orion on port 3030 a Sparkle endpoint, which is a clone of our website endpoint because we're going to be pushing to it, and I don't want to screw up the website endpoint. So let me just... Fortunately, there's no easy way to do this, so I'll copy and paste it.
So it looks like it lets you add multiple endpoints per view. That doesn't.
It lets you add multiple endpoints per view.
Yeah.
You mean so multiple instances of the semantic web component? Yeah. So you'll see in the code editor how that can make sense.
Okay.
So basically, each semantic web component is a wrapper around the Jena model. So you can actually have multiple models. You can load different data sets from different endpoints into them if you wanted to. And you'll see in the code how we would actually kind of make some decisions about how to use that. The last thing, before we actually head over to the code, I'm going to grab a button and just title it Save. And so we're going to use that as basically our indicator that we need to push back the data once the form has been completed. Okay, so just a quick summary. You can double check if you're following along. We have the screen 1 at the very top, semantic form 1, and then nested underneath that, first name, last name. And then outside, we have button 1 and semantic web 1. So if we've got all that, we can go ahead and open the blocks editor. It will prompt you, your browser will prompt you most likely if you want to use this web launch object that gets downloaded. Firefox, I think, will just ask you to open it. Chrome, you usually have, at least for me, I have to come in and click on it a second time to actually get it to launch. Depending on your operating system, you may have additional dialogues you have to get through. It will start a Java instance for the AppInventor. Again, some additional dialogues, these from Java now, asking if I trust this system to serve me up code from the internet. I'm going to say I trust us. And then any second now, we should get a window, which is the blocks editor. So again, this is the interface as I showed it to you in the slideshow. You can thumb through all of the different sections if you like, just looking at what the available components are. So you have all sorts of string manipulation items under text. Under definition, you can actually define procedures and functions. You can define global variables. There's items for manipulating and creating lists. There is no native dictionary object, but you can simulate it using lists. It's like an A list from Lisp. you basically have lists of pairs, and then there's this lookup in pairs object that you can use to find a key, find the value for a particular key in a list. Some basic math operators for all the normal stuff you would probably do in something like Java, plus support for a number of math operations like square root, min, max, so on and so forth. Some basic logic, testing, and true-false values. Control, which we looked at a little bit in the slideshow, but there are also things like for-each loops, operations to launch other screens or close the application if you need to do so. Colors, so you can actually manipulate all sorts of things. There's, for example, there's a canvas object, and you can put balls inside of it, and then you can assign the balls colors, then do little animations and things like that, make the balls bounce around, and so on and so forth. And of course, using that media section, you can actually upload additional content and use that. Under the My Blocks section, it loads. It's taking a very long time to load. How many people are actually following along? Just a show of hands. All right, we may. It's a dual-core processor machine. It might not be handling it too well. Okay. So once this loads, what we'll see is a number of definitions on the left-hand side here representing all of the different components that we just added. So you'll see each of these 6 items show up in the list. Still loading. Okay. See, it always works easy when you have one person testing it. When you have 20 people testing it, it doesn't quite work anymore. Just for...
Is this because everyone who's following along is hitting Orion?
Yeah. But I'm just gonna, well, before I make any claims that it's the fault of all of us doing it. Well, it doesn't look like it's that bad. Let me try relaunching it real quick and make sure that it wasn't some other issue. And I think I've got network connectivity just fine, so.
Are you plugged in?
Yeah, no, I'm plugged in because I'm streaming. I'm streaming from the computer,
okay,
so
okay.
It wouldn't make sense to do it any other way.
Yeah.
Okay. Oh. Actually, I guess you can already tell. So this loads a jar file from Orion, and you can see just how long it's taking to do simple things. That something is overloaded. It's not clear what. Okay, there we go. I probably caused problems because I deleted stuff from this application. Like I had done some basic things to play around, and I didn't delete all the code first, so it probably was messed up. Okay, so maybe you all saw that. And okay. This is very, very strange. I must have something cached. It's not showing me the right project.
What is it showing?
It's actually showing me a previous project where I was playing around with the Bluetooth components. So one of the many things you can do in here is there's a lot of items for kind of interacting with other components on the phone. Bluetooth being one of them, so you can actually build basic games with this where you have 2 phones talking back and forth and sharing data. There's kind of social components, so you can drop in a little Twitter object so you can have people tweet from your application. John, sign in the Skype. John, Patrick wants you to sign in the Skype. All right. I'm just going to quickly go through and make a second copy of that project because there's a lot of crud coming up. So this is one nice thing, because it's really easy to work with, it's easy to recover from, potentially. It doesn't require a lot of interaction. Okay. Try again. So brand new project, no leftover cache files or anything of that nature. Should be in better shape. Do I have blocks? I do have blocks. Great. Okay. Now we're caught up. I didn't name them first name, last name like I did when we were going through it the first time, but just bear with me for that slight inconvenience. So what you can do now is, if you come under the Semantic Web 1, which is our component for kind of interacting with the rest of Semantic Web, we'll see there are a number of various actions in here and events. So all these green blocks at the top here are events that happen in response to some of the actions we'll take a look at. The one we're going to play around with today is the publishing of a graph. And so the first two items there, fail to publish graph and publish graph, are kind of where you need to be oriented. A number of these other things, for example, we provide mechanisms for retrieving Sparkle queries from the web, so you can just throw a file up containing a Sparkle query, pull it down, and then use it to execute a query. Retrieving results of a select query, and then kind of handling some additional error conditions when talking to endpoints. Again, Semantic Web component wraps a Jena model, so you have the ability to interface with it at an RDF level. You can add triples to the model. This execute query executes against the endpoint specified in the previous screen. And let me just flip back and show that. So this endpoint URL, whatever we specify, will be used when you call execute query. And of course you can change the value of that. There are getters and setters for the various fields at the bottom here. And then lastly, a reference to the component in that. Not this particular component, but the form component will be used in a second. So the first thing we're going to do is we're going to go to the button. And we're going to put in a handler for the event click. Right, so why they chose click and not tap, I'm not entirely sure. But we'll go with click. So when the button is clicked, what do we want to do? Well, barring spending a lot of time on validation of the data, we're just going to kind of assume that we filled the form incorrectly to save on time. And what I would like to do is I would like to triplify my form, and this actually will return true or false value, whether it's successful or not. So I'm just going to drop in an if and an else here. And then I can go and I can grab my Semantic Web component and drag in that I want to triplify a form. And then under form, the semantic form, I can actually go and grab that particular component and drag it in. And the kind of high-level algorithm here is that the semantic web component goes through and recursively kind of digs through the form and all of its contents to identify fields that are capable of supporting linked data, which means that they have the concept URI and the property URI fields, turns those into triples, and populates them into the Jena model. And then, if that's successful, we can go ahead and under semantic web component, we can publish that model. And we need to give it a graph. And so the easiest way to do this usually is to, you can say subject URI for form, which will go through and figure out what the URI of the form is based on its contents. And we'll do that. Okay. And then just for some basic validation, if it fails, we're going to set the text of the button to failed. And then if it succeeds, we'll just set it to success. And to do that, in the semantic web form, the semantic web component, rather, again, we have those events at the top. We can publish. If the graph is published successfully, then we'll set the text of the button to success. And there's the failed component as well. So if for some reason it says that it's still save after a few seconds, we'll just kind of assume it failed. But you could go through and build that up. So the next thing, for demonstration purposes, again, I'm going to do this in the emulator. But for those of you who have devices and have them hooked up, you can feel free to connect to your device. But you come in here and you click on this new emulator button. So again, this package contains the entirety of, or a lot of the Android SDK in terms of utilities. It has the Android debug bridge, which allows you to connect to your phone and load packages onto it to view the error logs and all of that stuff. It allows you, if you use that, to also to kind of set breakpoints, if you will, so you can stop on a certain function, for example, if you need to look at it, examine things. But it also contains the emulator, so if you don't have a device set up and capable of debugging things, you can always just debug it in the emulator. There is a performance hit. It doesn't emulate as fast because it's trying to emulate the entire hardware stack. So generally, I tend to debug on my device if I have it around. And of course, I would encourage you all to do the same because you can actually see how well it's going to perform versus potentially having the emulator's performance influence your perception of how it's going to perform. And I guess I would also apologize to the people who might be listening on the live stream. My fan is probably pretty loud right now because I'm using my entire CPU emulating a phone and encoding video streams.
Patrick is following along, and he seems to be following along pretty well.
All right, that's good.
You have to make it clear, though. It wasn't clear that how you got the emulator.
All right, yeah. So from the blocks editor, up at the top here, there are a number of buttons. New emulator being the one that generates a new emulator. If you have your device, you should be able to hit connect to device, and you should see your device listed on this list. There's also a Wi-Fi version, which I won't get into. You can go to the AppInventor website and read about how you can do it over Wi-Fi. But for now, we'll just assume that we're connected. Once your emulator has started and you're at the screen where you can kind of swipe to open, you can pop back into the blocks editor and just select the emulator from the list. And what that'll do is that will have the blocks editor. It will generate all of the necessary code. It sends it off to the, well, in this case it doesn't actually. So there's an app. When the AppInventor gets built, it builds basically the app to rule all apps, essentially. It contains every component, and it has a REPL essentially built into it. And then the blocks editor sends it the code, and it actually runs it. There are also, while that's building, I'll just explain this. There's a package for phone, which I talked about in the slide deck, where you can come and you can package the application a number of different ways. This actually gives you a file that you can give to other people and they can put on their phones. That actually sends it off, builds the entire application on a server, and then sends back the resulting executable. So that's an alternative way, and that's an actual way of distributing. For example, you could take that APK, go to Google, sign up for the Google Play Store, and then actually upload that APK if you wanted to. So how are we doing? Still connecting. I guess while we wait on that, I will just go through some of the other components and keep that off to the side so we can keep an eye on it. So, in addition to the basic components, there are a number of objects for interfacing with media. So, for example, you can set up a camcorder. You can actually use the camera on the phone to do video recording or just regular picture taking. You can, similarly to doing that, you can have players for media, either playing video clips or sound clips. The image picker allows you to actually get access, well, not get access necessarily, but to ask the user to pick images from the gallery. For example, if they have an existing image and you want to maybe build a little social app where they upload an avatar or something like that. I've already mentioned it previously, but there are these various sprites that you can use to animate and build little games and things like that. Social, a number of pickers to find information about contacts or emails. You can launch phone calls or texting services. You can also receive SMS messages, and I know there are a number of other people working on various messaging services as features here. Sensors for interacting with a number of the different sensors, including the locations, so you can access GPS data, accelerometer if you want to make maybe an accelerometer-based game, or orientation here is, I believe, the compass, so if the phone has an electronic compass in it, you can use that for orienting. Arrangements, so by default, things kind of arrange going vertically down the screen. If you want to arrange things horizontally or in a table, there are alternatives here. This actually works with LEGO Mindstorms, so there are a number of items here for interacting with the Mindstorm sensors. Semantic web we've already gone through. A number of other interesting components. Barcode scanners, so for example, you could, if you had a database of UPC codes and you wanted to, and maybe you had some linked data about that, you could have people scan a barcode, perform a SPARQL query, pull back linked data about that particular barcode. That we had the folks from the OGC, I think a few weeks ago, talking about fair trade and all of that, and being able to kind of build a little app based around validating information using a barcode would be an interesting opportunity. I mentioned Bluetooth a little while ago, that you can build games and things by setting up Bluetooth server and client and having the phones pair up and talk to each other.
So these are, just to be clear, these are standard components.
So these are standard components. So basically everything I'm talking about right now while we wait for this thing to start except for the semantic web, is already in the AppInventor. Right? So you could go on to appinventor.mit.edu and play around with it, right now. But I figured I'd give you a little taste of all the different things that are in there. Maybe get some ideas flowing. We could have discussion after the talk is over if people are interested in potentially building some applications. Did it finally go? Or did it fall asleep? All right, I'll keep talking. There's a notifier where you can pop up notifications or dialog boxes to prompt the user for information during the running of the application. There's some support for speech via either speech to text or text to speech. There's this tiny WebDB, which actually some folks have played around with using this as a way of accessing linked data. Basically, it's a simple HTTP GET request is all it does, but you give it a key and a value. And so some previous folks have actually set up like a PHP service that you can point this thing to, and then as part of your GET, you give it the URL of a query, and it will execute that query and give you the results back as a text format. But it's limited to only manipulating strings. So the semantic web component that we've implemented actually treats things as bindings as lists, for example, so you can actually iterate over them easily, and it makes it relatively straightforward to manipulate it. Oh, we'll try it again. So we might not be able to demo this in the emulator, but in that case, I'll load it on my phone and we can maybe pass it around.
So could you talk a little bit about the cycle between bouncing between the blocks editor and the AppInventor itself, the online? So if I want to add a block,
yeah.
What do I have to do?
Save
online and then you would see it automatically?
Yeah, right, yeah. So when you don't have a lot of people hitting it, yeah, that information gets transferred. There's actually a socket open when you launch the blocks editor. So it loads information about the project, and basically both of these are really talking to the backend server. And each one kind of polls every few seconds to see if there's any data changed. And as part of that, if I were to add a component, that sends a message to the server. The server uses that to update its version of the project. And then in the blocks editor, it's pulling as well, so you'll see it show up. And similarly, it's supposed to do that if you delete things as well. I didn't have it open at the time. But if you... if I were to delete, for example, the button, you'd see the whole button event over here that we've constructed disappear. And so that way it kind of helps keep things kind of straightforward, that you don't have random events floating out in the world that never get fired but still have code associated with them. So that's helpful. May just have to give up on that. It doesn't seem like it wants to run. There's too many things going on. But the idea here, and what I was going to show, is you eventually end up being able to push back to this endpoint. So if I just do a select distinct and it's XML. You'll see that there are, because I played around with this and I tested it before. So TWeD.rpa.edu is the graph that contains all of the website data. And then I created a sample person myself, and that's how we got the graph example.com/AppInventor there. And then you could take this graph and you could look at the RDF data inside of it. And so I had a slightly more complicated form using the list picker, where I populated it with the people from the website, and I simply had it do a FOF-NOS relationship. But you see, we have a first name and last name, which is our existing form, just text boxes where you would type in your data. You'll see that it types Evan Patton to be of type FOF person. Again, as we specified in the concept URI field. And it also gives some additional information because concept URI is also on the list picker, so it types John Erickson as a FOF person and so on. So it tries to do some basic things like that. One thing we could think about maybe is doing some basic RDFS inference. For example, if you try to, the list picker works using RDFS label. So if you tried to query for me and expected me to show up after we built this application, it wouldn't work. And that's because we never set an RDFS label, so it never shows up. But one thing you could do is you could maybe have a field code for FOF name. And FOF name is a subclass or a subproperty of RDFS label in the FOF ontology. So if you were to perform that inference, you would eventually have that I have this label, and then I would show up in the list. So there's a lot of potential expansions to this. And this is really kind of meant to just give you a simple taste. And I would encourage you all to play around with it offline and give me feedback on kind of how easy it is to use the semantic web component. And if you have suggestions, I'd be more than glad to hear them. So with that, and with the emulator not working, I guess we'll call it an evening. Do you have any questions?
Checking with Patrick. Okay. Might actually have some. He's asked a couple along the way.
This thing seems like it's just stuck. I don't know. That's the problem with emulators. And all right, let me see if I can load it on my phone real quick, and then we can.
So in order to interface with the phone, do you need Mac or Windows?
You should be able to do it with Linux as well. The Android development kit has support for all three operating systems, so I expect that they've packaged all three of them and made it available. Because the blocks editor is just done in Java, so as long as you have a recent enough version of Java, I would expect that it would run. Although I think there might be compatibility issues with OpenJDK, but I think I read that somewhere, but I guess don't quote me on it.
So with the emulator, how do we know if it's working?
How do you know if
well,
it's
working? I mean,
how do you know if it's saved?
It looks like a phone and it's charging says it's 50%.
Right.
Show the app, should it go straight to the
you have to connect, if it's set up and you actually see all that, you say connect to device, and then it will say emulator. And then it should try to connect to it. That was when I kept doing it.
I see, that's where you brought up the
Right, so for me it was just kind of it should pop up in a few seconds. Yeah, so one thing I tend to do usually is I tend to download the APK because I use a newer version of the Android debug bridge. And so I've got it all set up at my console and it works splendidly.
We've got incoming from Patrick.
Okay.
It's the same state that it is. Patrick, did you have a question? Okay.
So I got it loaded on my phone anyway. So where the emulator fails, at least we can try it out here. So do we want to have a name for our new individual? I didn't really think of one beforehand. Mr. Joe.
It's a terrible name.
Joe Smith? Mm. Oh, man. How about Tony?
There we go. Tony's a good one.
Tony's a good
That's
one.
a winner. Sounds great.
Tony Smith. Yeah, it needs to be more Italian. Like, more Italian last name.
So,
Yeah.
mine started up.
It did start up? Okay. Yeah, I think it's probably just because I'm running so many things that are timed out. Alright, so my phone says success now, so if we pop back over to Chrome real quick, we can just verify that that actually worked. Okay. Tony Smith, okay. I didn't set the URL, the base URL properly. That's alright. So I'd assume that the base URL should just be the graph store URL. So yeah, Tony Smith is now in our graph store. So that's kind of generally how it works. I apologize I wasn't able to show that on the computer for everyone to see, but if you've built the application and followed all the same steps, you can build it and then run it on your phone as well, and then start publishing data tools. So that's that. I guess any other questions if Patrick doesn't have them. Well, so you have to write a basic one, right? I mean, I'm not doing any reasoning in here. You would have to build some web service where you do the reasoning. And right now, we've talked about trying to support the general rule engine. So in theory, if you could support something like OWL Lite, where you can encode it all with general rules, then you actually might be able to do the reasoning right on the phone. But as it stands right now, there's no way written into it that it would do that, and you definitely wouldn't want to implement, Tableau reasoning blocks.
So the question that Patrick had was whether AppInventor has a natural way for extending, for adding components, or do you have to actually hack the AppInventor code?
No, there's currently no way. You have to check out the code, add your classes, recompile the whole thing from the bottom up, and then redeploy. So it would be nice if they had some more modular design where you can just create a component and then plop it in. But nothing like that currently exists. I'm not aware of a timetable, but I can talk to the folks that have to do that.
And his reaction to that is, ouch.
Yeah.
Depending on how much you change, on my machine anyway, it takes up to 10 minutes to compile, so it's also very costly for debugging separation.
Ouch. Real ouch.
But that's the way it works. I mean, you're building an entire programming language when you do that. Is
this getting forked back in, or is this going to that's getting into the main branch?
Well, that's something we're trying to work out. Right?
Yeah.
So there's a project at MIT in the Decentralized Information Group, which just to wrap up, since I have 2 more slides. All right, summary, feel free to contact me. That's my email. Again, my email. I'd like to, of course, recognize Google for originally building the AppInventor, MIT Center for Mobile Learning for taking it over and open sourcing the whole thing. I've been working with the Decentralized Information Group at MIT to actually do all of the semantic related stuff. And then the National Science Foundation for supporting my research as well. But yeah. I'm sorry, who? So Lalana's the PI on the project, and then it's Fu Ming and Ilaria and in that group. So I know Hal is also in Div, but we've been kind of doing it separately from this mobile learning group.
Is Scratch, does that have a similar extension model? Or,
So it's graphical. I don't know about how easy it is to extend because I haven't really played around with it myself.
Because there's a huge community and it's hard to believe it.
Yeah, I would doubt if you want to really kind of keep extending it that this would be the way to go. There are a number of design limitations to it. So, for example, if you add a new property, you have to actually change code in 4 or 5 different files before you're actually done adding the property. So, doing manipulations in and of itself is cumbersome as a developer. I would certainly be open to trying to build a more modular system or having someone else build a more modular system to make it easier. But that's how it goes.
And did you say they were interested in disaster management and trying to do?
So they're working on a disaster management project for QCRI, which is the Qatar Computing Research Institute, and so they're looking at how can you kind of build a disaster management app, like in response, so a hurricane hits, and how do you, if you've got someone who's ambitious enough, could they build a small app that would help first responders get information they need or something like that. So Alana is in charge of that. Yes. I've already picked John's brain a little bit about that. So.
Pretty much there. All right, any other questions? Let's thank you, Evan. Remember, sign up for your lightning talks. Limited spacing. Everybody
around is going to do one.
3-minute talk, you can get it done in 2. 99% of the people get it done in 2.
Read the rules.